we've seen how to fit regression models with higher order complexity in terms of the degree of a polynomial. The next topic we're going to look at is how to fit similarly flexible functions but using splines. And remember, these are piecewise smooth functions. They can be piecewise constant if it's order 0, piecewise cubic if it's a cubic spline, and the order, typically cubic splines are the default for modeling smooth functions, but we can use constant to linear, quadratic, cubic. Okay, so as we might want to use splines in a regression setting, we've implemented something like the poly function for using B-splines. And you can construct B-splines using this B-spline object we've written in the ISLP library. And this is a scikit-learn transformer. So you see it has the same interface. We fit and transform, and this will produce the B-spline basis for specified by the number of knots and, well, whether or not you want to include an intercept, etc. So when we fit this in a regression model, though, we don't use the transformer directly. We use this helper function. This is like using the helper function lowercase poly that we saw above. So we'll fit the same model with these splines, and we'll get, we can summarize it again and look at the individual estimates. Though for a B-spline, the individual coefficients are often less informative. It's really the form of the function that's more interesting. So we'll look at a plot of the B-spline instead. Okay, so I'm skipping over some of the details that go into how B-splines are described. And we're going to talk now about natural splines. Remember, natural splines are special cases of B-splines that are subject to extra constraints, and that is that beyond the last knot, they just are extended linearly rather than cubically. So they look like a B-spline in the middle, but they extrapolate slightly different. Okay, so there's a degree of freedom associated to the spline, which is related to how many knots, so where the breaks in the discontinuities in the derivatives occur. So using 5 degrees of freedom is close to using a fifth order polynomial in some sense. It uses the same number of parameters as a fifth order polynomial, though it does it in a slightly different fashion. Let's take a look at the regression model. And actually, if we think back to the plot of the fourth order polynomial, the fit is not that
very similar.
Yeah, very similar.
Yeah.
Though the natural splines have, they typically will extrapolate a little bit better because they extrapolate linearly. Polynomials can grow very quickly beyond the edge point. So that's one of the nice things about using a spline instead of a polynomial.